here. I wanted to make another video. I think yesterday I made a video on the SARIMA model on the Johnson & Johnson dataset in R, and the thing that I noticed was that it didn't work out very well. And the reason why it didn't work out very well was because when I was setting up the order, some of the orders went into error. And because they went into error, then I couldn't use them. And I noticed that there is a seasonal element in the SARIMA model. So I decided that I was going to do the program again, but instead of using an SARIMA model, I was going to use a SARIMA model. Now, a SARIMA model is a seasonal SARIMA. And so that's what you use when you have a seasonal component in your time series dataset. So the SARIMA stands for S for seasonal, AR for autoregressive, I for differencing, and MA for moving average. So those are the 4 components that are in the SARIMA model, and R does all of that for us automatically in one inbuilt model. And the difference between R and Python is R is a program that's made just for statistics. So it has a lot of statistical functions built into it, but Python is a general purpose language, and so what you have to do in order to accomplish the same thing in Python, you have to use libraries. And there are libraries in R, but I'm just going to try to do all the work that I do using R's inbuilt functions. So the first thing that we're going to do is we're going to create our program, and we're going to use Google Colab because I really like Google Colab. Google Colab is a fantastic free resource from Google. And in order to use R programming language in Google Colab, because it's generally set up for Python, you type into the browser https://colab.research.google.com/notebook #create equals true and language equals R. And what that will do is that will set your Jupyter notebook up so you can program in R. So that's a fantastic thing about Google Colab, is you can program in Python and you can also program in R. And I just recently found out about this way to program in R, and I think it's really fantastic. So we're going to call up the Johnson & Johnson's data set, saying data brackets Johnson & Johnson. And then we're going to call up the class, find out what class it is. It's a TS, that means it's time series. We're going to call up the structure, and it tells you it's a time series with 84 cells in it, ranging from 60 to 1981. And basically what you have is you have the year 60 to 1981, or 60 to 1980 really. And then, so it's divided in quarters because we're going to be looking at the earnings per share. So it starts with 1960, number 1, and it ends with 1980, number 4. We look at the length of the Johnson & Johnson data set, and that's 84. That means it has 84 cells of data. We're going to look at the summary of Johnson & Johnson. The mean is 0.44. The first quarter is 1.248. The median is 3.51. The mean is 4.8. The third quarter is 7.133, and the max is 16.2. And so the thing is that with the difference between the median and the mean is the average of all the values, which is 4.8, and the median is the middle of the value. So the median takes into account outliers, whereas the mean doesn't. So the mean is the average and the median is the middle. So we're going to view the Johnson & Johnson data set. So you can see each row of data is here, and you've got the 4 quarters. It's interesting though, because it says the first quartile is 1.2. It says the minimum is 0.44, and your first quartile is 1.248. Your median is 3.5. Your mean is 4.8. Your third quartile is 7.133, and your max is 16.2. So we've got the max over here in 1980 and the min in 1961. So we're going to perform a scatter plot, and then when we perform the scatter plot, we're also going to put a regression line in the scatter plot so you can see what direction the data points are moving in. So that's, again, we're going to use a linear model as well, but you can pause your video and write down the code if you want. And this is the scatter plot that we have created, and you can see that the earnings per share are increasing annually, but it's not necessarily increasing in a linear format. It's increasing in a nonlinear format. So it would be a polynomial. It's a polynomial plot. Is what it is. But you can see the linear model is going up every year. So what we're going to do is we're going to do a line plot. So you can see the line plot in Johnson & Johnson data set. And so the line plot is very easy to create. It's plot brackets Johnson & Johnson, comma, color equals purple. So there's your line plot. And again, when you see the line plot, you can see that the earnings per share are increasing. Now, we performed it in SARIMA in the last video that I did, so I'm not going to perform the SARIMA in this video. We're just going to go straight to the SARIMA. But one thing that I will note is you can see I wasn't really 100% cool with that. I mean, it didn't, what shall we say, the order that we used, I wasn't 100% with that. And that's why I decided to go ahead and use the SARIMA and see what happens. So this is your SARIMA. The SARIMA is an ARIMA with a seasonal element to it. So if your time series has a seasonal element in it, then it's better to use the SARIMA than the ARIMA. So we're going to set the grid search out for PDQ, and that's going to be 0 to 2 on each one. And the reason why, if I tried to 0 to 8 on the P and the Q, it would take just absolutely forever to run through that grid search. So in order to do it quickly, which is what I like quickly, we're just doing it 0 to 2. And the best AIC is a goodness of fit test. It stands for something, and so I think that you want to have the lowest AIC you can get. Then you've got your best order, and you've got your best seasonal. And then we create a series of for loops for pi and P, for die and D, for y and Q, and then for capital P to P, for capital D to T, for capital Q to Q. And then the order is the C brackets pi, comma, die, comma, q. And the thing is that the C tells you that you're putting the elements together, and that is the difference between Python and R. You don't have to have any kind of C or anything like that to put it in Python. And then Python, a list and array are exactly the same. There's no distinction between a list and an array, but in R, there is a distinction between a list and array. But in the seasonal, you're going to have a list, and which is different from an array. Now what we're going to do is we're going to do the try-catch, which in Python is try-except. And so what you're going to do is you're going to run through the ARIMA model, and it's a seasonal ARIMA. You're going to run through the ARIMA model in every configuration from 0 to 2 for the PDQ. And it's similar to the PDQ for the ARIMA model, except it's longer because it has a lot more elements in it. But I am leaving it on the screen so you can pause the program and write down the code if you want to. And then so after it's run through the SARIMA and it has picked out the best order, and then what'll happen is it's actually a function. So y equals Johnson & Johnson, so that's your y, and your grid search equals SARIMA grid search brackets Johnson & Johnson, comma 4. And the reason why you say 4 is because you have 4 columns of data. Each column of data is representing a quarter. So we go through ARIMA, and so we just use 0 to 2 for each one. And the reason why we use 0 to 2 for each one was because it would take us forever if I tried 0 to 8, because I don't have a powerful computer, and my computer is old anyway. So it runs through the 0 to 2s, and so the best SARIMA is brackets 112, that's your order, times 0, 1, 0, and then brackets 4, and it has an AIC of 96.14. So in this particular instance, it's looking for the AIC. It's not looking for the RMSC. And let me just look at the best AIC equals best AIC. Let's see what it says here. It says best AIC equals best AIC. Let's just see what it says. AIC equals fit $AIC. So there's actually an AIC in the SARIMA model. So the SARIMA model is calling up the AIC. So after we've got the optimal order, then what we're going to do is we're going to manually put that into the seasonal ARIMA. So fit becomes ARIMA bracket Johnson Johnson, comma, order equals C, comma, C colon 112, comma, seasonal equals list, brackets, order equals C010, period equals 4. And then we summarize the fit, and so you can see the summary. And then we forecast the fit for the next 12 quarters. So this is going to be the next 12 quarters. And you can see this is the prediction that it made. And it also, it says prediction here. So we haven't printed our predictions, but you could say predict. And the good thing about R is it will accept Python code. So if you're a Pythonic like me, it will accept Python code. So if you want to actually see the predictions, then you just do print pred, and it will do that for you. It will print your predictions. So I'll try to run it. It's going to take a while for me to run it, but I'll try to run it. So it's done the SARIMA. It's doing the fit seasonal REMA here. Or it's doing the SARIMA, actually. It's still doing it. So we've got our predictions. So you can see the actual predictions for 1981, 82, and 83. It also gives you a standard error. And then so it's printing off in the graph the predictions and the standard error. So that concludes your SARIMA. I hope that you got something out of it. If you like my video, please like and subscribe. And thank you for watching my video. And I look forward to giving you some more videos with R content, Python content, and other data science subjects.